All right, so this was the U try, and this was on page 152, number 16. And what's good about this one is that it was already in standard form. So basically, all you have to do is solve for x. Now, factor, quadratic formula, synthetic division, whatever it takes for you to get these two values for x, factor theorem, go ahead and do so. I am a factorer. That's what I do. So here we go. A times C on top, B on the bottom. A times C is positive 54, and the bottom is B, and that should be a negative 15. So I'm looking for factors of 54. 1 times 54, 2 times 27, 3 times 18. Oh, I think that's it, because no, that's not it. They have to add up to 15. That subtracts to 15, so that's not it. 4 doesn't go. 5 doesn't go. 6 and 9. That's the one. So you can see how you could be confused and do 3 and 18 or 6 and 9. The determining factor is this right here. And because this is a positive, they have to add up. The sum has to be 15. So that would have to be 6 and 9. To make the 6 and 9 a negative 15, they both have to be negative. So it should be an x minus 6 and an x minus 9. This was an awesome, awesome factoring problem to look at. Yay. So we've got x minus 9 and x minus 6. And that's greater than 0. So that means that our roots are x equals 9 and x equals 6. Our y-intercept, of course, is 0, comma, 54, because that's our constant. And this is a quadratic. The a is positive, so I'm looking for this thing to start up and end up. It's time for us to make our sketch. All right, so got a little smudge here. I don't know what that is, but we've got our scaling there. I didn't feel like putting 1, 2, 3, 4, 5, so I just started with 6, 7, 8, 9. 54 is up top. And here's the thing we have to focus on. Make sure you know that these are open circle roots or x values. Okay, they got to be open circle because they don't have an equal sign. So this needs to be open 6 and an open 9. The 54 stays close because it just has to do with x values. We also want to make sure that we look at, I'm just doing this while I'm talking here, the inequality and the fact that this is a greater than 0 means we're looking for all the y values that are larger than 0 and what x values produce those y's that are bigger than 0. So we're looking for this to be above the x-axis. I can tell you that it dips under between 6 and 9. Everywhere else, it goes above the x-axis. So pretty much the x-axis gets shaded all the way to the 6. And then from the 9 all the way out to infinity. These are all of the x values that produce y values that are bigger than 0. That's what we're looking for, y values that are bigger than 0. And the x values that produce them are the solution. So this one is going to be a parenthesis, negative infinity, comma, 6, and that's a parenthesis because it's open, union, and then another parenthesis with the 9, and we're going to do a comma and a infinity with another parenthesis. So this is the solution to your, you try it, quadratic inequality.